Almost every day, people use different machines designed to use invisible forces they barely think about. Vacuums clean our homes using moving air, while airplanes use airflow with their wings to lift hundreds of tons into the sky. Even though these technologies seem completely different, they both rely on the same concepts, the motion of fluids and pressure. In this video, we will explain how fluids like air create pressure, how moving air changes pressure, and how those principles allow vacuums to clean and planes to fly. In physics, a fluid is any substance that can flow. Most people only think of fluids as liquids such as water, but it actually also involves gases. Fluids move from areas of high pressure to low pressure. Pressure is the amount of force applied over an area. In the equation, P equals AF, P is pressure measured in pascals, F represents force in newtons, and A represents area in square meters. These concepts are important because both vacuums and airplanes depend on changing pressure in order to create movement and force.
Here you can see how a different amount of pressure is exerted when using the same force in differing areas. Here are some real-life demonstrations of how fluids interact in your everyday life. Here, differing nozzle diameters change the speed of flow. Most people think that a vacuum sucks dirt in. However, this is not the case. The way vacuums work is that they create a lower pressure inside the vacuum so that the outside air pressure is really pushing the dirt in. Inside a vacuum, a motor spins a fan very quickly, pushing this air out, lowering the overall air pressure inside the vacuum as seen here. Because fluids move from high to low pressure, the fluids move into the vacuum, bringing the air to the liquid. Similar to this, For this project, it is actually very helpful to understand how a vacuum works. So, the vacuum demonstrated in the video uses this hose in order to suck up everything into the vacuum. As previously discussed, vacuums use fast-moving air traveling out of the actual vacuum in order to create a pressure difference within the vacuum to cause the atmospheric pressure to flow into the vacuum. So, in here, you see where all the dust and everything goes into, as well as an air filter, not an air filter, but a filter to filter out all the debris and stuff that goes into the vacuum. So, you can see here the hose that is connected to the outside that is sucking stuff in. That's quotes. And then here, you see on the side, if I can get it, this side little thing. This is what's actually shooting the fast air out in order to create a pressure difference within the vacuum, thereby causing the atmospheric pressure of the outside of the vacuum to push all debris and stuff into the inside of the vacuum.
Basically, what Bernoulli's principle says, that as a fluid speeds up, the pressure around the fluid decreases. In Inside a vacuum, the fast-moving air creates a low pressure inside, thus creating the suction typically associated with a vacuum.
Airplanes also rely on fast-moving fluid to generate lift as opposed to moving dirt. In this section, I will explain how a massive object, such as an airplane, was engineered using fluid mechanics to generate lift. Airplane wings are curved with a curved upper surface and a flatter lower surface. This shape is called an airfoil. As the airplane moves forward, the air moves faster over the top of the wing and slower underneath it, creating a pressure difference where the pressure above the wing is less than that below, and the existing air pressure under the wing pushes up and lifts the plane up. The equation A1V1 equals A2V2 explains that when a fluid flows through a smaller area, its speed increases. In the equation, A represents area and V represents velocity. This relationship helps explain why air speeds up as it travels over the curved top of the wing. A simple paper demonstration can show the same principle. When air moves quickly over the top of the paper, the pressure above it decreases, causing the paper to rise upwards. The same physics that lift the paper also help airplanes fly.
Here is an impeccably handcrafted version of how planes work with fluids. Please enjoy. Here is another demonstration of our previously shown airplanes and how they flew during test flights. Systems use fast, flowing air to manipulate pressures just for different purposes. Vacuums use it to create a difference of pressure in the machine and generate suction. Airplanes use the difference of pressure to generate lift for the vehicle. Both cases rely on Bernoulli's principle. Many of which we tend to take for granted. From household vacuums to airplanes, pressure and airflow allow modern technology to function. By understanding